Hey everyone, this is Jonathan from Chegg Tutors, and this lesson is on the light year, which is, I know it sounds like a time, but it's actually a distance traveled by light in one Earth year. And I say it's one Earth year because we measure years by the amount of time it takes for the Earth to revolve around the sun. So the light year is not a measure of time, it's a measure of distance, and it's just the distance traveled by light in 1 year. So why do we use this measure of distance? Well, we can't really use inches or feet when we're dealing with things in regards to space because the distances between objects in space are so enormous that we need a larger measure of distance. And in this case, it's light years. So just as an example, beyond our solar system, the two closest stars to us other than the sun, Alpha Centauri A and B, they are 4.22 light years away. So it takes light from those stars 4.22 years to get to us. So when we see this light, we're actually seeing those stars 4.22 years ago, which is really cool to think about. So let's now get the value for 1 light year. So the speed of light is normally represented as c, and c is equal to 3.00 times 10 to the 8th meters per second. Now, in 1 year, there is 3.115 times 10 to the 7th seconds. Now, if we multiply the amount of seconds in a year by the speed of light, we'll get meters per year. So if we do 3.00 times 10 to the 8th meters per second times 3.15 times 10 to the 7th seconds in 1 year, we get 9.46 times 10 to the 15th meters per year. And that's how many meters that light will travel in 1 year. So this right here, 9.46 times 10 to the 15th meters, is the value for a light year. And in miles, just so we can make it relative to something that we normally deal with, this is 5.88 times 10 to the 12th miles, which is extremely far. So I know that using some distance that light takes to travel in a year is kind of strange for some people because light seems to travel instantaneously. But this is only because when we deal with things that involve light, we're pretty close to them. So for example, when we flip a switch in our room, the light seems to travel instantaneously because we're only a few feet away, and we can't really measure that amount of time that it takes because it's such a small amount of seconds. But if you were to travel at the speed of light, you would be able to encircle the entire globe 8 times in 1 second, which just shows you how fast light travels. So there's some interesting side effects of the fixed speed of light and viewing objects in space, and viewing them by this distance of a light year. So say we are looking at a star here. And here's our Earth all the way here. Now this distance is 11 billion light years. What that means is that the light from this star took 11 billion years to get to us. So we're seeing this light that traveled 11 billion years to get to us. So we are actually viewing the star 11 billion years in the past. So right now, if we were to view a star 11 billion light years away, that star would most likely not even be there at this very moment, because we're seeing the light from 11 billion years ago, and right now at this moment that star's probably not there because the light that we're actually viewing from this star is 11 billion years old. So that's really cool and very hard to wrap your head around at some points. But another interesting side effect is that if, say, there's some civilization 65 million light years away and they're viewing the Earth, they see light at this very moment that has traveled 65 million light years, which means that the light is from 65 million years ago, which means that they would be seeing dinosaurs right now on the Earth, which is pretty cool. So I hope this helped and showed you about the speed of light and the distance it takes to travel in 1 year. And my name's Jonathan, and I'm on Chegg Tutors.